Hello friends, welcome back to my YouTube channel. So in today's video we will solve one more problem of how to develop the flexibility matrix. So in last video we have solved one problem. Today we will see one more problem. So this is the given problem. Develop the flexibility matrix for the beam with respect to the coordinate given. So here already coordinate are given. At point A coordinate 1 is there, at point C coordinate 2 and 3 is acting, 1 is vertical, 1 is movement is there, and now we will see how to calculate the flexibility matrix. The first thing what we have to do is redraw the diagram by removing all the loads. So I am redrawing here again to find out the reactions. We need to find out for each coordinate separately. Here coordinate 1 is acting. So we need to apply the unit load of 1 kN to find the reactions. Here reaction RA takes place and here reaction RB takes place. Now we need to calculate the reaction separately. And summation of all the moment about A is equal to 0. Clockwise we need to take the positive. Here RB is acting anti-clockwise. Distance here is 3 meter. Here also 3 meter. And this is point A. This is point B. So now RB is acting at the distance of 3 meter. So minus RB it is because moving anti-clockwise, minus RB into distance of 3 meter, plus here one unit load is acting, that is 1 kN clockwise. So plus 1 is equal to 0. So now simplify it, our RB will come out as 0.3. Similarly for RA we need to apply the summation of all the vertical forces is equal to 0. Upward we need to take the positive. Here RA and RB are the upward, moving upward. So we need to take the vertical forces only. So RA plus RB value we got was 0.3 is equal to 0. So now RA will come out as minus 0.3. So here the negative sign what indicates is the upward direction that you gave is wrong. So make it as downward. So RA is moving downward. So I am making it as downward. Remove this upward. The value is 0.3. And here RB is also 0.3. So similarly we will calculate for the coordinate number 2. So it is overhanging, vertical load is acting at coordinate number 2. I am again redrawing the diagram. So we need to give the here unit load of 1 kN. Here also 3 meter distance, here also 3 meter. This is point A, point B, and call it as point C. Now for this also we need to find the RA and RB reactions. And here RA will come, RA will takes place at point A, and here at point B RB will takes place. Now we will apply the summation of all the moment about A is equal to 0. Clockwise we need to take the positive. Here RB is moving anti-clockwise. RB into distance is 3 meter. So minus RB into 3, plus here one unit load is acting. So it is moving downward. So it means it is moving clockwise. So at a distance of 6 meter from. And now RB will come out as 2. Similarly we will do for the RA. Summation of all the vertical forces is equal to 0. Upward we need to take the positive. Here RA and RB are the upward forces. So RA plus RB value we got was 2. Here one more vertical force is acting downward, that is 1 kN of unit load. So minus 1 is equal to 0. So now simplify it, our RA will come out as minus 1. Again it is downward. It means the negative sign what indicates is the upward direction that you gave is wrong. So make it as downward. So I am making it as downward. So RA is minus 1. And this now similarly we need to calculate for the coordinate number 3, that is one unit moment is acting at point C. Again I will redraw the diagram here. So here 1 kN of moment is unit moment is rotating. So now we need to find the reactions for this diagram. So here Ra takes place, here Rb will takes place, and so now we will find the reactions. Summation of Ma is equal to 0. Clockwise we need to take the positive. Here Rb is moving anti-clockwise, so minus Rb into distance is 3 meter. Here on unit moment is rotating clock. Plus 1 is equal to 0. So now simplify it, our Rb will come out as 0.33. Similarly, summation of Fa is equal to 0. All the vertical forces we need to take here. Ra plus Rb value we got was 0.33. So Ra will come out as minus 0.33. Again it is downward. We need to make it downward. So the direction which gave was wrong. So make it downward. This is how we need to find the reaction for each diagram. And here one more thing is the first diagram will call it as the M1 bending moment of coordinate number 1. This is M2 bending moment of coordinate number 3. This is M3 bending moment of coordinate number 3. So this is how we need to find the reaction for each the coordinate. Now we will see the table of unit load method. This is how the table will come. For member AB, I am taking the origin as A. For BC, I am taking the origin as C. And now we'll see the limit. For AB is here distance is 3 meters. So 0 to 3. For AB member limit is 0 to 3. And for BC member again distance is 3 meter. So limit is 0 to 3 for BC. Now we will see the bending moment for corresponding diagrams. So M1 is, see here, if we cut the section far away from the origin, so our origin we took A. So if we cut the XX section far away from the point A and at a distance of X, so it will come like this. So here intensity is 0.3, it is moving downward, so minus 0.3 into at a distance of X. So our M1 is minus 0.3 into distance of X. Here one more moment is unit load is acting, that is 1 kilonewton. It is moving above the section. Above the section we need to take the positive, so plus 1. Similarly for M2, see for the diagram 2. If we cut the section far away from the origin A, if you cut the section XX far away from the origin A at a distance of X, here our intensity is 1 minus 1. So minus 1 into at a distance of X. So our M2 will be minus 1 into X. Similarly for M3, if you cut the section XX is far away from the point A, this is point A, this is point B. So cut the section XX is far away from the origin A. Here intensity is 0.33. So it is moving downward. So make it as downward. See here it is negative, no? Make it as downward. So direction is downward. So minus 0.33 into a distance of X. So our M3 will be minus 0.33 at a distance of X. Now we will see for the member BC. I took the origin C here. So this is the point C. So here point C will come. If we cut the section XX is far away from the origin, there is no load, no, there is nothing, so it will come 0. For M2, if you cut the section far away from the origin C, so section XX is far away from the origin C at a distance of X. Here unit load of 1 kilonewton is acting at a distance of X. So our M 1 kilonewton at a distance of X, our M2 will be minus 1 into X. It is moving downward above the section. It is moving, so we need to take the negative. Similarly for M3, so if you cut the section far away from the origin C at a distance of X, so where unit load of 1 kilonewton is acting, no? At a distance of X, 1 kilonewton moment is acting. For that minus 1, it is moment, no? For this we need to take the minus 1. So see here, where we have taken +1. So why we have taken positive here? This unit load is moving above the section. It has a positive effect on the structure, so that we took the positive here. Here we have taken the negative. So this load is moving downward. That means below the section. Below the section we need to take the negative. So that's why I have taken -1. This is how we need to fill the table. Next we will calculate for the flexibility matrix. So the given formula is delta is equal to F11. This is 3 into 3 matrix. So that's why F11, F12, F21, F22, F23, F31, F32, F33. So now we need to find the F11, F12. So by using the formula which I have shown while explaining the working procedure. So for F11 we have the formula, this one. So integration of 0 to L m1 square divided by EI into dx. So by using that formula we will calculate the F11. So F11 is equal to integration of 0 to L m1 square divided by EI into dx. So now I am taking 1 divided by EI outside, it is constant. 0 to L, so see here our limit is 3, 0 to 3. So put that limit 0 to 3, and m1 is minus 0.3x plus 1. For BC it is 0, we only take this one. So minus 0.3x plus 1 whole square into dx. So now integrate it by using Cal C. So integration of limit is 0 to 3. So our value is minus 0.3x plus 1 whole square. So solve it. It will come out as 1.11. So F11 value is 1.11 divided by EI. Similarly, we will calculate for F2. We have the formula, this one. So substitute all the value here. So our M2 value is minus 1 into x. For BC is minus 1 to x. So we need to separately integrate for these two. So now we will see minus 1x whole square dx for AB. Integration of 0 to 3 minus 1x square dx for BC. So now we will separately integrate for this. So integration of 0 to 3 minus 1 into x whole square plus integration of 0 to 3 into minus 1x whole square. So now solve it. So it will come out as 18. So F22 value will be 18 divided by EI. So 18 divided by EI. Similarly, we will calculate for the F33. So F33 is equal to, we have the formula integration of 0 to L m3 square divided by EI into dx. So 1 divided by EI I am taking outside, it is constant. Integration of 0 to L. So limit is for AB 0 to 3. M3 is minus 0.33x. For BC our M3 is minus 1. We need to add these two. We need to integrate separately. For 0 to 3 value is 0.33x square dx plus integration of 0 to 3 minus 1 whole square dx. So now integrate it separately for these two. Integration of 0 to 3 minus 0.33x whole square plus integration of 0 to 3 into minus 1 whole square. So solve it. So our F33 will come out as 3.98. So 3.98, F33 value will be 3.98 divided by EI. So similarly, we need to calculate for the F21 and F12. So F21 is equal to f12. We have similar formula for these two. Integration of 0 to L. We need to take the moment of the first point. Here first point is 2, so m2, and here first point is 1, m1 divided by ei. So we need to multiply the moment of first point. So 1 divided by ei, integration of 0 to 3, and m2 value. m1 value we got was minus 0.3x plus 1, and m2 value is minus 1x. For BC, 0 into anything will be 0. So I am not taking it. I am taking only for AB members. I am integrating it 0 to 3. So our minus 1x minus 0.3x plus 1 into dx. So integrate it. So by using calci. So integration of 0 to 3 into minus 1x into minus 0.3 x plus 1. So plus 1. Now solve it. So our f21 and 1 will come out as minus 1.8. So our value will be minus 1.8 divided by ei for f12 as well as 21. Similarly, we need to calculate for the f31 and f13. So f31 is equal to f13. We need to take the 0 to L. Moment of first point is 3 here. First point is 1 here. So m3 into m1, or you can take m1 into m3. Both will be same divided by ei into dx. So 1 divided by ei constant, I am taking it outside. Integration of 0 to 3, and m1 value for AB is minus 0.3x plus 1 into minus 0.33x. And here 0 into anything will be 0. I am not taking it. I am taking only for AB members. So I am integrating it minus 0.33x into minus 0.3x plus 1 dx. So integrate it. So by using calci we will solve it. So integration of 0 to 3 into minus 0.33x, bracket close, again bracket, minus 0.3x plus 1. So solve it. So our f13 will come out as minus 0.59. So f31 as well as 13 value is minus 0.59 divided by ei. And now we'll solve for the f32 and 23. So f32 is equal to f23, integration of 0 to L, moment of first point here also first point, m3 into m2 divided by ei into dx is equal to 1 divided by ei. I am taking outside into integration of 0 to 3, and m3 and m1 value for AB is minus 1x and minus 0.33x. For BC is minus 1x into minus 1. So we need to integrate it separately. Minus 1x into minus 0.33x dx plus integration of 0 to 3 into minus 1x into minus 1 dx. So now solve it. So by using calci, integration of 0 to 3 into minus 1x into minus 0.33x plus integration of 0 to 3 into minus 1x into minus 1. So now solve it. It will come out as 7.47. So f32 and f23 value will be 7.47 divided by ei. So this is how we need to calculate all the values in this matrix. So now put all the value. f11 value we got was 1.11, and f12 will be, minus 1.8 divided by EI minus 1.8. Here also minus 1.8. Similarly for F13 is F13 value we got was how much? Minus 0.59. Minus 0.59. Here also minus 0.59. And our F22 value we got was 18. So 18, and F23 value we got was how much? We got was 7.47. So 7.47. Here also 7.47. Finally our F33 value we got was 3.98. 3.98. So I'm taking EI outside, 1 divided by EI. So this is how we need to fill the flexibility matrix. This is how we need to find all the values by using the formula. If you like the video, like it, share it and subscribe for the more videos. Thank you for watching.